A fixed-wing drone equipped with 5 cameras was utilized to create a high-fidelity, 3-dimensional model of the entire city, using the oblique photography technology. The 3-dimensional model contains more than 200 million polygons. In this analysis, the nonlinear time history analysis of buildings on a regional scale considering site-city interaction effects is implemented. Specifically, the buildings are simulated using the nonlinear multiple degree of freedom models, and the site is simulated using the 3D spectral elements. The ground motions of Wenchuan Earthquake are simulated using the Tsinghua supercomputer. Subsequently, the ground motions are adopted to simulate the interactive seismic responses of both the buildings and the site of the entire new Beichuan City. The influence of the complex terrain can be considered in this study, so as to produce a more reasonable analysis result. For example, the seismic accelerations at the top of the mountain is evidently different from those at the bottom of the mountain. By combining the regional seismic damage simulation of buildings and the fine 3D urban polygonal modeling, the nonlinear seismic responses at any time are visualized in high fidelity for every building and every floor. By combining the building model from oblique photography with nonlinear time history analysis results, the seismic responses of buildings are visualized in high fidelity. For special buildings, we can further establish their refined finite element models according to the design drawings, so that the seismic responses of every component of the buildings can be obtained. Then the simulation results can be combined with the building models obtained by oblique photography as well. High-fidelity, realistic visualizations of seismic responses of building clusters are also implemented by combining the regional seismic damage simulation and the oblique photography models. The ground motion at New Beichuan City in 2008 Wenchuan Earthquake simulated by Institute of Xinzheng, China Earthquake Administration is used as input. Cool technologies behind the video. One of the key challenges for seismic damage simulation is to obtain a reasonable ground motion input. The seismic wave propagation from source to fault to the site is a complex process, limited by computer capabilities. Previous studies generally can only simulate low-frequency seismic waves. In this study, we cooperated with the team of Professor Hao Huanfu from the National Supercomputing Center in Wuxi, which has the fastest in the world Tsinghua supercomputer, powered with the Tsinghua supercomputer. The full-band, strong-motion simulation of the 2008 Wenchuan earthquake at the new Beichuan City was performed. Complex terrain and dense buildings may have a significant impact on the surface ground motion. As a result, the interaction between the site and the buildings should be properly considered. The buildings can be simulated using both the nonlinear multiple degree of freedom models and the refined finite element models. We further cooperated with the team of Professor Gang Wang from the Hong Kong University of Science and Technology to develop a computer program. Using such a program, the soil model of several square kilometers and hundreds of buildings are put together, and the seismic responses are calculated considering the site-city interaction effects. Another key issue in this study is to obtain the high-fidelity facade images and design data of the buildings. With the support of the Earthquake Disaster Mitigation Bureau of Beichuan County, we investigated the relevant design drawings of buildings. Moreover, in cooperation with Professor James Yang from the Institute of Xinzheng, China Earthquake Administration, a vertical takeoff and landing fixed-wing unmanned aerial vehicle developed by China was launched, and more than 14,000 images were captured. Subsequently, the 3D building models with more than 200 million polygons were generated using high-performance computer clusters. The resolution of the 3D models is 0.035 meters.